Here we are. Worksheet that was due yesterday. So I'm not going to necessarily write on this. I can't. I have to go back to the whiteboard thing. But here we go. CUS is ion. Oh, let's see. Huh. Interesting. CUS is ionic, metal, nonmetal. SiC is network solid. The other ones are SiO2, diamond is one. Those are the most common. Graphite, germanium, silicon, but SiC, SiO2 are the most common that I see typically. NH3 is polar covalent. CH4 is non-polar covalent. CO is metallic, just a piece of metal. Remember, NH3 is polar because it's not symmetrical. CH4 is symmetrical. I know some of you want to use the odd, even business there. Again, that's good, but if you just bank on that, that's not going to really work out for you. So again, with the NH3 and CH4 really quick here. NH3 looks like this. It has symmetry maybe this way, but not that way, right? So, and it has unequal distribution of electrons and charge. You have the electrons there. All right, I know I'm going fast there. And CH4 is very symmetrical with equal distribution of electrons and charge. So there's your balance, some symmetry, nonpolar. All right, let's go back here. All right, forget carbon forget cobalt. Increasing bond strength. Weakest would be dispersion forces, CH4. By far, dispersion is the weakest. It's not even close. In fact, if you knew the physical states, which you don't, but if you did, CH4 is a gas, NH3 is a liquid, CUS and SiC are solids. So gas, liquids, right? So CH4 is the weakest, NH3 is next, because that's a little stronger because it has polar covalent using hydrogen bonding as its force. So that would be the N and the H from opposite molecules. And then the two solids would be next. So this third line would actually be ionic, CUS, and then SiC would be the last one. Network solid, by far, strongest substances on the planet, SiO2. That's how you make sand, glass. Typically, silicates are in granite as well, if you just understand how hard that is. So really high melting points for network solid. All right. CUS, electrostatic interaction. What is that? That is essentially that right there. So you have a Cu giving 2 electrons to sulfur. It becomes Cu plus 2. Sulfur becomes sulfide. That positive-negative attraction is actually called an ionic bond. That's electrostatic because opposite charge attraction in chemistry, just in science in general, is called electrostatic. So that's electrostatic in ionic bonding. NH3 uses hydrogen bonding. CH4 uses London dispersion because it's nonpolar. Dispersion are pretty much, so nonpolar molecules, and like Hankel-Griffiths, only use dispersion. NH3 is polar covalent. It uses dispersion because everything does, but it also uses hydrogen bonding, which is kind of takes priority. Hydrogen bonding stronger, so that one has both. CH4 only has dispersion. HCl, because it's polar, has dipole. That's just like carbon monoxide as far as the attraction. Define and circle which. All right, intra is stronger. It's not even close. Intra is a bond, and then inter is a force. And just really quick, I will use HCl as an example here. When you have a dot X Cl dot 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 dot, you do that dot structure and you get that single covalent bond around right there. That's intramolecular. If this is attracted to another HCl molecule over here, because of the dipole moment, Cl is partially negative, H is partially positive. This attraction is the dipole interaction. That's intermolecular, and then the bond itself is intra. Sorry, that's messy. Super weak compared to this. When you boil, melt. I said this the other day. I sound like a broken record, but if you took HCl or water, let's say, and you boiled it, you're breaking that so that these molecules are going to spread out and make a gas. You're not breaking the bonds. Like when you boil water or freeze water or melt water, it's still water. The bonds are intact. You're just separating molecules or letting them get closer together, depending on what you're doing. All right, so that's that. I think that was it. Yeah, all right. Let me stop that.